Here are examples how to integrate more complicated functions using this formulas. Number 1. Evaluate the integral of y dy over square root of 25 minus 16y squared. Let's try this formula. Integral of du over square root of quantity of a squared plus u squared equals to arcsine of u over a plus c. Get the values of a and u. U is equals to for y, and a is equals to 5. The derivative of u is for dy. Let's compare this to the given. As you can see, they are not the same. The one we solved has a coefficient of 4 and doesn't have a variable y. Important tip: we cannot modify or correct the derivative of u if a variable or function is missing. We can modify with the coefficients only. Since the denominator is in radical, maybe we can use power formula. Transform the integrand into this. And we have our u equals to 25 minus 16y squared and equals to negative 1/2. The derivative of u should be negative 30 to y dy. Compare the given, they only differ with the numerical coefficient. It means we can modify the derivative. Now, let's use the du equals negative 30 to y dy. If we added negative 30 to here, we should add negative 1 over 30 to left side of the integral sign. Copy negative 1 over 32 and use the power formula. Simplify, and you will get the answer. For the number 2, let's change the exponent into 4. Simplify it as per the formula. We get a equals to 5, u equals to 4y squared, then solve for its derivative, that is 8y dy. As we compare the derivatives, we notice that they only differ with the coefficient of 8, so we can modify it. Since we added here a coefficient of 8, we must also add 1 over 8 at the left side of the integral sign. Copy 1 over 8, then use the formula from the item number 1. For the item number 3, evaluate integral of dz over z squared plus 6z plus 10. Now, before we simplify, let's look at the formula we can use for this item. We have this, integral of du over a squared plus u squared is equals to 1 over a, arctangent of u over a plus c. And the hint is, we need to get to perfect squares in the denominator. Let's factor 10 into 9 and 1 to get these two perfect squares. Now we have a equals to 1 and u equals to z plus 3. Solve for du, which is dz. Since derivative is the same as given, we don't need to modify the derivative and can directly use the above formula. And this is the answer, arctangent of quantity of z plus 3 plus c. Now, let's try this more complicated problem. Evaluate the integral of quantity of for x minus 7 dx over x squared minus 6x plus 13. Let's try the method we've done in item number 3, by transforming the denominator into two perfect squares. We have x minus 3 as u, and 2 as a, the du is dx. By comparing the derivative, we can easily see that this formula is not applicable because of the 4x minus 7. Let's try using the denominator as u and solve for its derivative. If we compare to x minus 6 and for x minus 7, the only common between them is that they are both linear. Question: can we modify this? The answer is yes. It's actually simple. We modify for x minus 7 that will transform into a function that involves to x minus 6. Like this one, to x minus 6 should be multiplied with 2 to get the term for x at the left. Then we should add 5 to get the term negative 7. You can check the result. Now, let's use this instead of for x minus 7. Arrange to the most favorable form. Here we use x squared minus 6x plus 13 as the denominator. And here is the two perfect squares as the denominator. Here we use the formula of integral of du over u. And for this one is the integral of du over a squared plus u squared. And here is our answer. For the last item, integrate 3dx over square root of quantity of x to power of 4 minus 9x squared. By investigation we cannot use this formula, because the both term in the denominator under the radical sign has a variable x. Let's simplify it first. As you noticed, it is in the same format as the formula of integral of du over u, square root of u squared, minus a squared. We get u equals to x, a equals to 3, and the derivative of u is dx. There is no need to modify the derivative. And the answer is arcsecant of quantity of x over 3 plus c.